sicker. I think we're ready to go, gents. You ready to go?
Just a sec. Okay, now.
I think we're ready. It is SBAU Astro Hour time again, everybody. Program number 242 for October 13th through the 19th in the year 25. I'm your proud host, Ronnie Heron, retired radio morning anchor who used to invite these same guys on the screen onto my wake-up talk show for kicking around cutting-edge cosmology for Santa Barbara, California's longtime Astro and Telescope Club, the Santa Barbara Astronomical Unit, headquartered up in the Santa Barbara Museum of Natural History, Mission Canyon. Hey, find out all about us, the club at sbau.org. Stand by to meet my very knowledgeable friends on the screen in a moment. But first, here's this week's topics. M33s up in Triangulum. Check it out in the eastern sky before the moon rise. Speaking of the moon, it's last quarter, either this morning or happening this sometime around now. Weather says it's waning. Actually, my weather says later on, but the moon is waning. Actually, we're talking about the moon. It's a Leo next to Regulus. And there's a real lemon of a comet making a splash in the pre-dawn sky. It's C/2025A6. Just happens to be named Lemon. You ever considered, folks, how they get these stunning photographs of comets and their incredible tails? It's called stacking multiple images. And why do star magnitudes count backwards? They get brighter the lower the number. It's something called stellar magnitude system. We're going to talk about that. And we're going to take some time to talk about time. Ever heard of relativity of simultaneity? Ooh. And incidentally, we'd like to congratulate the three winners of the 2025 Nobel Prize for Physics. Two of them happen to be professors out at our university, John Martinez and Michel Devore. The other guy is up at Berkeley, where Alex Filipenko hangs out.
Oh.
Say again?
Oh, no, I didn't realize. I wonder if that's Filipenko's team.
No.
Well, he probably knows them. Is Filipenko in charge? He was our speaker this month, a couple of weeks ago. Is he in charge of the astronomy department out there? Does anybody know? I think he is.
Yeah.
He's not
the top guy. Well, listen, come join us at a first Friday general meeting or a second Saturday night star party up at the museum. I see we have the whole crew on board today, so let's meet the commander of the Starship, Astro Hour of the crew, Jerry Wilson, married to the lovely Pat Ford.
Good morning, everybody, and good morning to Riley and to Calvin and to my sister Joyce.
That's right. If you three aren't watching, you'll stop announcing your names. God love you. As co-pilot is Captain Outreach, Chuck McPartland, in front of the Ukraine flag with his favorite cat. And he's trying to stifle a sneeze because he's allergic to cat. His wife, Pat, is both our club's merchandise manager and treasurer, probably within earshot. Science officer is Tom Whittemore. How you doing, Tom?
Wow, I've been promoted.
We're just going
Congratulations.
We're going on board the Starship here. He's former science instructor with Westmont. Every time we see him, we smell sourdough bread. He's editor of the club's newsletter and married to Maureen.
Tom, you gotta wave like this now.
Oh, I can't do that. I can't do that.
I can't either.
I'm one of
The
those.
navigator of the Starship is Tim Crawford, resident lens expert. There he is, longtime member. Wife is Karen. And even though he asks as many questions as I do, he knows far more than I do. First mate, onboard Vulcan. And there he is with pointed ears, Bruce Murdoch, who is using his cell phone to get on board with his visible. He's the Santa Barbara Theater Organ Society president, and his wife is Bonnie. Tim, you're married to Karen, and we are ready for sillies to get us in a good mood. These are now condensed and sent in one email or two by the president to us during the week. Our silly science cartoons, a couple of them are thought provokers, and let's hit the screen and make that a little larger, please. This is the man and woman playing chess at the table. There it is. And we no color. She's got beautiful yellow hair on mine. But he says to her, they're playing chess, and he reaches over, aha, gotcha. She says, I wouldn't move here if I were you. And he says, maybe you just can't see what I'm doing. Maybe I'm playing 12th dimensional chess. He says, maybe my moves have a genius that your brain can't even comprehend. She reaches over, moves her bishop, and goes, checkmate. And he thinks about it, in the 12th dimension, I would have won. Only made it to what, 10 or 11, I think. There's that many of them. Here's the mathematics professor on stage. It's washed out because we can't see what's on the board. You got to recalibrate that, Mr. President, because it's full of stuff we wouldn't understand anyway. Most of us don't get all those formula that some of our speakers bring. Here it is.
Ah, there.
All right, he says, gentlemen, this image illustrates my theory that presented with a sufficient quantity of intricate formulae, overcomplicated diagrams, and impenetrable acronyms, an audience will always agree with almost anything. And they go, yeah, you're right. My thoughts exactly. Here, I quite agree. Excellent point. Like a Neil deGrasse
Now,
Tyson.
the board is meaningless.
Oh, come on, they have the force of gravity up there, and
Yeah.
All right.
Yes, Newtonian gravity.
There's a crystal on the right side.
But I mean, as a whole.
yeah,
Like a whole.
I agree.
All right, here's a couple of dinosaurs. People probably don't know that throughout the history of evolution, every era had its own paleontologist, and they dig up the past. And here's a triceratops saying, hey, look, Professor, a stegosaurus, the bones of one. And if you guys remember the names you always remembered or you learned when you were growing up of the dinosaurs, I think the guy on the right is a Diplodocus. I'm not sure.
It could be. I don't remember.
It's a
that one.
parasauropod.
Oh, is that what it is? Well, it had a horn or crest or something, but he said,
Yeah,
Jurassic.
that's actually a big cavity in their skull that helps them yodel or whatever.
That's right.
Make sounds.
Yeah.
But anyway, the point of this is that the age of dinosaurs before man was so long that these are extinct. These are dinosaurs digging up previous dinosaurs that were billions of years extinct.
So the Stegosaurus was not in the same period as these two guys, I guess.
Yeah, the one on the right, Ron, is Parasaurolophus.
Okay.
Really?
Yes.
Well, any of you ever heard of the word Diplodocus?
Yes.
Yeah.
I thought it was a plant eater. I'm pretty sure it wasn't a meat eater.
Yeah, but they're like they're like Apatosaurus or the former Brontosaurus.
Well, we're learning new ones now. Don't buy plastic skeletons for crying out loud for Halloween. It's terrible for the environment. Locally sourced, all natural skeletons.
Jesus.
Yeah, get your ancient
God.
ancestors out of the grave. They're
That's
more
gruesome.
Just don't get caught harvesting one.
That's
Yeah.
right. Down in Mexico for their Day of the Dead, they just paint them on.
Okay, now this pun is for Tom.
Go ahead and read that, Mr. President. Tell us this joke.
Horse walks into a bar. The bartender says, "You're in here a lot. Are you an alcoholic?" The horse ponders for a minute and responds, "I don't think I am," and poof, he disappears. This is where philosophy students start to snicker, as they are familiar with René Descartes' postulate, "I think, therefore I am." But telling you that first would be putting the Descartes before the horse.
Right.
Oh, God.
Well, some people we know that can't think aren't here, as far as I'm concerned. All right, here's the moon shrink, and that would be Dr. Albedo. That's a word with meaning, isn't it?
Yeah,
Albedo.
Dr. Albedo.
Albedo. He's the blue moon shrink, counseling a fellow moon, our moon, I guess, saying, hey, think positively, and you can be a super moon just not a few days or times a year, but every day. Come on.
Yeah,
Right.
change your attitude.
Right now. All right, here is looks like an alien couple, just extraterrestrials having crashed into one of the occulting asteroids. She just won't let him talk about, nice job, huh? Now, how did you expect the high beams to work when you're flying faster than the speed of light, idiot?
Now, this is wrong on several levels. First of all, you can't travel. Nothing can travel faster than the speed of light. But at the speed of light, light is always, you can't catch up with your own light.
Right.
Really?
So,
Would it go faster then than the speed of light?
no, you can't get there. But if something was traveling faster than the speed of light, it couldn't slow down to the speed of light without infinite energy. And time would run backwards for it. So those old Superman comics that show Superman zipping around the earth faster than the speed of light so he can go back in time and save someone. Half the concept is right, but he couldn't go that fast.
Well, this is a cartoon, but does that look like a married extraterrestrial couple?
Yeah,
That's okay.
Yes.
The one of,
this is a cartoon, but it's funny because of misconceptions of physics.
well, I'm still trying to grapple with the fact that the universe is expanding now faster than the speed of light, so some light will never reach us.
The faraway part of the universe to us appears to be moving faster than the speed of light to us.
So the light it gets emitted from way far away, goes through the infrared and then radio waves and down to
Microwaves. The farthest
microwave.
we can see away when the universe was, what, 300,000 years old. That stuff is in the actual flame, so to speak, is in microwaves.
So we're going to reach the barrier. I guess we have already with the Webb. Got
There's
lots of
parts of the universe that we will never be able to see.
Yes.
Well,
So anyway,
let's
this
talk some of these.
this is a bright an object, a faint fuzzy that's in the opposite part of the sky from where the moon is. So you have a chance to-
You got to share screen.
Oh, I'm sorry.
All I saw were 6 talking heads.
Yeah.
Dim objects.
See that?
Yes.
Yes.
Okay, good. So anyway, this object is M33, the Pinwheel Galaxy, which is a bright galaxy in terms of total brightness, but it's spread over such a big area that it's actually very faint. If you're under really, really dark skies, you can see both Andromeda up here, and you can catch a glimpse of M33 with your naked eye.
Just did that 4 weeks ago, Jerry.
Okay.
You can see them both.
But it's a dramatic object, and it's away from the moon in the sky, so you have a chance of seeing it with our amateur telescopes. This is a picture of M33, and it's been processed so that you can see the hydrogen alpha regions in it, where they have star-forming processes going on. That would be the equivalent of our Orion Nebula. And these are sprinkled around the arms where they're making stars. This is a picture from the Very Large Survey Telescope at Paranal, Chile. And it is, I don't see the name of the guy that took it, but anyway, it was a group of astronomers.
The Barge spiral.
What's that?
Barge.
No.
No, doesn't appear to be.
Okay.
Yeah, it's got a kind of a tight nucleus. There's a little brightness there and a little, but it's not anything different from the arms coming out of it. So it doesn't look like it's spiral to me.
It's blown out on the display, so it looks a little bit elongated. Is
Oh,
why.
okay.
Yeah.
Okay.
That big blob in the upper left there of red that's like got a separate down. Come down. There you go. I think that's got a separate NGC number. That's like a huge Orion Nebula.
Yeah. Now, all the stars you see in this picture are in our galaxy. They're not at M33 or between us and M33.
Okay.
It's a dramatic object.
Right.
Now, this one is a nice, tight little object called the Saturn Nebula. It's a planetary nebula. And let's see, where is that? Whoops. Yeah.
That's a drawing right there.
Yeah, this is a drawing of the Saturn Nebula taken by Lord Ross with a 6-foot diameter reflector in the 1850s. He really had a good scope.
And this is spooky somehow.
He's what?
You tied it in with the season, spooky.
No,
Oh,
this
spooky.
is the Saturn Nebula.
Yeah. The tone of this thing in Astronomy Magazine is, which I got a lot of this from, is that this ties in with the season. We're seeing spooky and diaphanous things. And I guess the Saturn Nebula is also called the Ghost of Saturn.
But that's a ring around it?
No, you'll see.
Oh, okay.
This is what it actually looks like in our
Number?
telescopes.
Yeah, okay, that looks familiar.
Yeah. So if you kind of squint, look at this, and just before it fades out, you can kind of get the idea that it's a central object with maybe rings around it. But that doesn't mean the shape is actually that. These things, planetary nebula, are randomly oriented in space, and they can present all sorts of different interesting shapes, like butterflies and ants and stuff, just from the angle we're looking at it.
Wow.
Well, Lord Rosse's drawing doesn't really agree with the photograph that's below it.
Well, it's got a central core, and it's got some bright or not thing out here. And if you're seeing things very faintly, which they probably were in Ireland, even with his scope,
Yeah.
it kind of looks like that.
Okay, so this is just the middle part, the part that we see in the astrophoto that's white around the nucleus.
Plus the red blobs.
Yeah.
Oh yeah, okay, and he thinks those are a ring or something.
Those aren't real rings, but they present an aspect that is reminiscent of Saturn's rings.
Mhm.
Yeah.
Probably jets.
Yeah.
You know, interestingly enough to me, despite all the shapes that are in geometry, there's only really two that are represented throughout the universe, isn't there? Rings and orbs or globes. You'll never see a pyramid. You'll never see a square or cube. Nothing can be put out there. Those shapes, just rings.
There's a couple of planetaries that look pretty square,
Really?
Really?
and there's peanut-shaped ones.
Well, the dumbbell, right? That kind of looks square.
Yeah.
You say planetary. Is that the rocks?
Planetary
this one-
nebulae like this one.
This is the planetary.
Well, there's a couple of asteroids that are shaped like peanuts too, now that you mention it. And then there's the two moons of Mars.
Now the central star is seen here, or is that too washed out?
It's really washed out.
Okay.
Mm.
No, it's fascinating. We're going to talk about the moon. Is there a time on the first quarter? Was it this morning or
Last quarter.
It's last quarter.
Oh, last quarter. Did I write it down wrong? Oh, you're right. Last quarter.
Okay, see it now?
There you are.
Wow.
Okay, so
Oh, okay.
right there is the 11th magnitude white dwarf star that was the original star that sloughed off these layers as it stopped fusing anything in its core.
It's like an amoeba.
It does look like a translucent thing, yes.
Or a
It's a
paramecium.
barfing out stuff.
So 11th magnitude is not too faint. A 6-inch telescope will show you 13th magnitude stars. If you look at the M57, which is a round called Ring Nebula, the central star is 14th magnitude and you can't see it. This is much easier to see. Okay. Now, this morning, no, the October 13th, tonight at midnight, this is the what the eastern horizon looks like. So these objects are all rising. Here's the twins in Gemini, Castor and Pollux. Here is Jupiter. The size is reminiscent or is indicative of their brightness. And here is the first quarter moon.
Third quarter.
Last
Excuse me,
quarter.
you're right. Last quarter. You're right. Thank you.
Mhm. Yeah, I saw it come up, Jerry. It was really bright.
Uh-huh.
It's just also going to mention this is a time of the year that you can just about say good night to Arcturus and good morning to Arcturus.
Oh.
So, Arcturus is coming up just before 7 o'clock now.
Mhm.
Okay.
So I've always been confused. If we see Jupiter in the morning, how long will it be until we see it at evening?
Half year.
About 6 months.
Yeah.
Okay.
It's 2 hours a month.
Mhm.
So this
2
is
hours
coming
a
up.
month.
This is coming up about midnight.
Yeah.
That'd be similar to Venus.
So it'll be setting about noon.
It's
It's not as bright as Venus, but it's up there.
Yeah.
But I mean,
But it could-
Venus is morning or night star, depending. Is it 6 months apart?
Yeah, because
No.
it's an inner planet, it can't get very far from the sun. But Jupiter
Right.
get an opposition, but Venus can't.
Yeah, but
And
Venus
Ron-
isn't a 6 month period. Venus, because it's racing around inside, has longer apparitions.
Yeah, and Ron, since Jupiter takes 12 years to go around the sun, it migrates through the zodiac a constellation at a time every year. So next year at this time, it should be in Cancer the Crab.
Oh, how interesting.
Well,
And I've watched this summer. This summer was further up inside of the twins, and then now it's falling below, going towards Cancer the Crab.
Huh.
well, may I ask a question that maybe this could be standard stuff, but I've never heard it before. Is
What's
it
that?
possible that all the planets, inner or outer, are going at the same speed?
No.
Oh no.
Well, I
Yeah.
mean, obviously it's a much bigger track, so it would take longer, but do they get slower as you go out in speed and actual movements?
Yes,
They slow down.
They slow down.
They slow down as you go further away from the
right.
sun.
It's higher energy orbit, but lower speed orbit.
So Pluto is hardly moving at all. It takes forever.
Yeah.
248 years. Long time.
Because Jupiter's way out there. Only a 12 of our Earth years it gets around the sun.
Yep.
12 years, yeah. And so that makes it about a zodiac constellation per year.
How
Oh,
many-
there you go. Okay. This is interesting, guys. Okay. I'm all set.
Boy, good luck finding anything with this chart.
Holy smoke. All right, Mount Lemon. A
Yeah.
deer
Comet
friend.
Lemon. So on October 13th, the 23rd down here, it's really moving along. This is M3. This is
Mhm.
Coma Berenices that's going through Canis Venatici
Mhm.
and M63, M94. So it's a rich region up here.
Yes.
It's not an easy to follow chart in my view, as Chuck likes to point out. But
You can still see M3, don't forget, Jerry, before the sun goes, after the sun goes down. It's getting kind of low though.
yeah,
And Arcturus is just about down at sunset, right?
Right. So it has Tim as because it's so far to the northeast. So Arcturus is about 14 hours in the upper sky, and then about 10 hours down below us. Okay, so it's about a 10-hour trajectory from when you see it set to when you see it come rising up in the northeast.
10 hours. Okay. All right.
About 10. It's rough, Tim.
okay.
And this comet has been zooming in brightness.
Yeah. Oh, wow.
But now
It's at like magnitude 5 now.
so
Holy
Jerry,
wow.
will this comet be a morning comet?
Yes.
Mhm. Right now, it'd be,
About.
But Mag 5 is about visible by naked eye, isn't it? Just about.
Yeah, real dark skies you can see to magnitude 6 with good eyes.
Mhm.
With 80-year-old eyes, I don't know.
Hard to see the front door.
Yeah, I'm magnitude 212 at my age.
Wow.
Okay, this is a photograph of Comet Lemon
Nice.
by an amateur, I believe. Let me just check my notes here.
I think this one you showed last week, it's neat.
That was a slightly
This is the
different
same
one.
one as last week, but
Oh, wow.
I
this
see
is
two
by
tails.
Dan Bartlett, taken on September 26th, when it was higher in the sky and fainter.
I love that edge-on spiral at the very end of the tail.
Yeah,
Yeah, I was wondering what that
quite a
was.
capture. Anyway, this is a highly processed image. You won't see this with your eye. The camera takes a picture of this and it gets the stars and it gets the comet, but it's not very bright. So what you have to do with these astro photos, it's not like taking a picture with your camera during the daytime where the picture that you're interested in has enough light that it dominates the scene. And there's all these little variations and peculiarities and noises and fluctuations in the camera that all you can't see them. But when you take pictures over a long period of time of very faint objects like we do when we do stars, then you have to boost the light up electronically or using software after you take the picture. And one of the ways to boost it is to take, say, 25 frames right after each other or at different times for the fixed stars with short exposures. I usually do around 12 to 20 exposures about 5 minutes long. Now, if you did that with the comet, which would benefit the comet will move in those times. The stars don't. So you can just take those pictures and you can stack them one on top of the other, and they add up the brightness of the picture, and they subtract out a certain type of noise. So it's a good process. But comets are a special deal because they move with respect. So if we did that, we guide on the background and we take the comet picture. The comet is just this vague blur that goes across the final result. So what you have to do is you take each individual frame. Whoops.
Lost your cursor.
This is a processing chart for taking comet pictures, for processing comet pictures. And it looks really complicated, and people that aren't familiar with astro imaging go, oh my God, how do I do those things? Well, you don't have to do these things. For everything shown on this screen, there are software programs that will do it for you. For example, red, green, blue pictures taken with like a DSLR, your regular camera, or your cell phone, it has the filter in the focal plane, and separating out the colors into RGB colors is called debayering. You just put the picture in your computer and you press debayer and it does it. So you don't have to know anything about that.
Well, you might have to know how your Bayer matrix is arranged. And
you do have to know that.
Yeah.
But if there's ways around that, I'm trying to make it as simple as possible so I can trick fools. I mean, get people to try it out.
Yeah,
So,
Ron. Ron.
Yes, sir.
Yeah, I was going to say a technique people often use is to grin and bear it.
But listen, have any of you five gentlemen ever photographed a comet?
Yeah.
Oh, sure, sure.
Yeah,
With
look
my
at
cell
Jerry's
phone.
background is.
Did
Yeah.
you go through this process he's talking
No, I just
about?
took my cell phone and got NeoWise a
Yeah.
couple years ago, a few
So-
years ago.
So your pictures probably won't match these professional ones that go through this system then, right?
No, everybody goes through this system. It's like we gave a talk. One of our fellows is an avid amateur astronomer. He's no longer with us, Bob Richard.
Oh, yes.
I gave a talk on how to process images, and then later, a couple months later, he gave a talk on his images. And he started off by saying, you don't have to do it Jerry's way, because he thought it was too complicated. He said, you just get this software, you put it in there and stuff. And he says, you never know exactly what you're going to get, but sometimes it's really spectacular. And I said, yes, Bob, you do it exactly the way I do it, except you have a software automatically do it, and I do every step manually. It's all the same process.
But you got to go through those steps or you won't get that picture we just saw. Can you go back to that picture?
Well, it depends on the brightness of the comet. Some of them are
Yeah.
so bright, you can just take your cell phone picture and that's it.
Yes, that's true.
Am I
But
seeing?
like this is
Go ahead.
showing a lot of detail under high magnification. And so this comet would move, but you want to stack it to bring these stars out. And this comet would move during those individual frames. Some people
By the
take
way,
very
Chuck,
short frames, like 10-second frames, and they'll stack 100 of them.
Wow.
Tim?
by the way, Chuck, that little spiral in the tail,
Yeah.
that's the Starship Enterprise chasing the comet.
Well, I've heard that comets have two tails. Am I looking at two? Is there a shorter one just under the big wispy one?
I think you kind of are.
The ion tail is generally straight, and the whatever you call it, the tail is all the gobbledygook following it is all
Well, I think these are all the same tail. They're just fluctuations in it because the source of the tail is some frozen lake or something on the comet head. And one lake will start shooting something out, and then another lake will have its spurt showing things out. And so it's not, coming out in one jet. It's a bunch of different jets firing at different rates.
Yeah, and this
Well,
one
why
is
the
not.
that's down, why is the one that's down below that seems to end up on a star? I mean, that's an optical illusion.
That
Yeah.
is,
But that one looks quite straight. And all the rest of the tail is all wiggly.
Well, there are gusts in the solar wind
yeah.
from coronal
Oh,
mass
okay.
ejections and things like that. So that's what causes these disconnects and whirls in the tail.
And the comet head is probably rotating.
Yeah.
Solar wind, it acts just like our wind, blowing wispy clouds.
Yeah.
I've never seen a tail on a comet look like that. They're always exactly straight.
Oh, this is a very dramatic, yeah, because it's blurred.
Yeah,
This guy has put a lot of care into the processing.
but you're telling me you guys can take a picture just like that
Yeah.
with your scopes?
Look
Yeah.
at my background.
Okay.
Yeah.
Now, it's not as detailed as his because I used a very low magnification. But the idea is that you have to treat the stars. See, this is the star image process, and this is the comet image process. So when you align your stack of cards, you have to do it twice. You have to align them so the stars register with each other and the comet blurs out. And then you have to do it with the stars blanked out. This is the one with the stars blanked out, but the comet registered between frames. And then you put them all together at the end, called image flattening, I guess it was. But there's a lot of steps in here. There's a software right up front called Blur Exterminator. And that was one of the very new AI generated processing softwares. There are 3 of them they came out with: Blur Exterminator,
Star Exterminator.
Star Exterminator, and
I don't remember the other one.
yeah, I don't either. But they're just astounding. I mean, everybody uses these now because they're an order of magnitude better than any techniques that have been developed before. So this is Russ Croman plugins for PixInsight, and they're 3 of them, and each one costs about $50.
Now, Jerry, would you to blur out to get rid of the comet and then and get the stars in the background?
Yeah.
Would you use the blur exterminator?
Yes, because the blur, the thing is a fuzzy object. So
Okay.
it looked like a blurry image.
Wait, just a minute. That's the comet image creation on the left there. So you don't use blur exterminator. To get the comet image, to get rid of the comet, you do the thing on the right for the stars image creation. I mean, that's later on. That's a subpart, I guess.
Oh, really?
Yeah. Yeah, so you do this first part up here, and then you transition over to the right.
Well, this reduces the halo around the core and gives you a tight target to register on.
To do the alignment.
Register on a fuzzy topic. You want to register on as close to a point as you can get.
Oh.
But right in the middle there, you basically separate it out into 2 different images, one of just the comet and one of just the stars.
Yeah, right there, star removed.
So how do you get rid of the stars?
There are several techniques, but one of them, Star Exterminator, takes
That'll do
the
it?
stars
Okay.
out. That's the third AI we couldn't remember.
Third AI, we're talking artificial intelligence.
Yeah.
Well, does all of this apply to our interstellar visitor, the Atlas guy?
Well, it's a comet.
Yeah,
Okay. Have we seen a picture of it yet?
Yes.
several.
Oh, okay.
We showed one last week.
I couldn't identify it. This isn't it, of course.
No, this isn't it.
Atlas is in the word. Okay. Fascinating. How in the world? You just can't open your shutter and leave it open and take a picture and it'll give it to you. You got to go through all these.
But the comet moves.
Yeah,
Is that what it is? It's the moving part.
yeah.
That's
You have to focus on the thing that's moving to get its image sharp, and then it blurs the stars. but if you focus on the stars, then the moving thing is blurred.
Yeah.
Okay, guys.
So this is a picture of pan stars meeting, what was the meeting M10.
Yeah, that'd be an Ophiuchus.
Yeah.
I could see that in my bird binoculars in the in southern Utah. That globular.
Yeah. Now this is showing pages from Inside PixInsight. I believe this is PixInsight, or else it's registering and stacking. Yeah. So let me check my notes here.
Jerry's just gonna tell folks if they're out looking for this comet in the the western sky after the sun goes down and they're really disappointed, you can now see Mercury, so you won't be so darn disappointed.
Okay. So anyway, this is stacking things. It's working on a file, say 25 pictures, and it's stacking them with this point constant on each frame. So it stacks it according to this image, not according to the frame. It doesn't line the square frame up. So that's an example of doing it. And if you're in that, this is not PixInsight. This is CCD stack, I think. No, not CCD stack. Alignment the comments. Deep Sky Stacker. That's right. Now, Deep Sky Stacker. What's that? Deep Sky Stacker is free software. So some of these things are very expensive. I used Myra Pro 7 ages ago, and that one cost $700 for that program. But it does the best job of alignment, and it's very versatile. But there are several now that are free that are just as good, and this is one of them. This is what looks like inside PixInsight, and this is where you have the stars only after you separated them in that diagram. And this is where you have the starless frame showing the comets and a blur where the globular cluster is, because it got rid of the individual stars. So this is an unresolved picture of that. So this is starless and this is stars only. And you process each of these separately and then you put them back together and you get the type of picture you saw.
Now, when you combine them, what is that? Is that called, there's a name for that?
Yeah, there is.
Something down.
No, well, maybe down, but it's
flattening.
Flattening, yeah.
Flattening, okay.
That's because all the various things are different layers in your processing software.
Right.
And when you finally flatten it, then it puts it all together as one.
Yes.
And Ronnie, this is why the workshop, the telescope workshop, there's a lot of guys on there. And me knowing nothing, it gives me the opportunity to ask these questions. And they're really, really nice to explain them. All this stuff. It gets so complicated. It's unbelievable. So I ask them the same question on a routine basis, like every other month. I'll ask them the same question because I forget it.
I got to tell
but you get different answers.
Yeah. No, I don't. They're really good about it. They're really good.
You're like me. I have a great memory, but it's short.
The thing is, guys, you need guys like me and Tim because nobody would ask questions since you guys know it all.
Yeah, exactly. We're useful, Ron.
We're the little boy in Mr. Wizard's workshop going, gosh, Mr. Wizard, really? What happens if we pour this in here?
We got it going on, Ronnie.
That's right.
Well, between my brother and I, we know everything. So if somebody asks me a question I know the answer to, I say, well, my brother knows that.
There's a great line I liked in a 1930s film about Ma and Pa Kettle. If you remember those characters, they're in Appalachia, and they're rural people, very simple. And the IRS comes down because they haven't filed a tax return in a long time. And he's asking them something, and he asks her something, and she's Mrs. Kettle, and she answers it and stuff. And then he asks something else, and she says, just a minute, I'll have to get Pa. And so he comes down and he answers the question, and then she's left. And then he asks another question, and Pa says, wait a minute, I'll have to get Ma. And he goes, well, why do you keep switching these things back and forth? And she answers, well, when we got married, we decided there was no sense two of us knowing the same thing. It wastes brain power.
God.
Well, of the four guys that are with Tim and I, only one of you was a professor, a lecturer. The rest of you could have just as easily, I think, or we think, Tim and I, you could do a class out at Broida Hall easily, I think.
Tommy did, I think.
Oh, I taught at Broida, yeah.
Yeah.
That's what I'm talking about. He
Yeah.
taught.
Yeah.
But you guys learn, the rest of you, all of you, do you learn from these speakers we have every month, or do you know everything they're saying?
No, they've usually
They're
got something new to
mixes of-
say.
They're mixes of going from I knew 0% of what they're talking about before up to I know a lot of what they said before. Yeah.
So there are new things coming our way.
Yeah.
That's why astronomy is so great. It's expanding knowledge like the damn universe is inside.
Yeah.
I love
So
it.
anyway, this one moving along. This is the 16th, which I believe is Thursday.
Yes, that's right.
Thursday at 5 in the morning.
Mm-hmm.
And here you see the moon past last quarter, the crescent moon now
Okay.
is near Regulus in Leo the Lion. It's kind of fading things right near it out, but it's not really that bright like a full moon or anything. But it's a nice picture to look at. And one of the interesting things is, oh, geez, I've about run out of that software won't, it thinks I'm done.
Oh no.
So Friday, we have a crescent moon on Friday?
Thursday
morning sky.
very early in the
Yeah.
morning. Yeah, it's
Yeah.
a
Oh,
waning
okay.
crescent.
Okay.
The last of it, right? Get a new moon
Yeah.
next week.
But we're dark at Westmont.
Yeah.
Okay. Is AI
Oh,
shutting
I've got
us
two
down?
things. M30, forget that.
Oh,
There. Now this is a
Nope.
shot of regular.
Share it, Jerry.
I'm not showing it.
No,
Mm-mm.
Okay.
there we
This
go.
is-
There
This
you
is
go.
an artist rendering. Apparently Regulus is a 4-star system at least, possibly more. But the major ones, this is the major one that we see. It's a fast spinning giant star. It has a companion fairly close to it. And then it has two other companions that form a double star. This is not to scale, and it is not the pattern they're in. This is just a rendition of the objects in their relative size.
Or their relative brightness.
Yeah, the relative brightness representing the size.
But the shape is accurate, I gather.
This shape is a good guess.
Well, there's that
would be-
one that's an ellipsoid rather than being a sphere.
Yeah.
Yeah, it's spinning very fast. Some
I
stars.
know, I understand why.
Right, and that companion, that primary companion to Regulus is very easy to split in the scope.
Okay. Okay.
Very easy.
but somehow those four orbs orbit each other without colliding.
Yeah, I wasn't able to find a graphic representation of their orbits. So,
So they get as big as four. Binary becomes trinary, quaternary.
there apparently are possibly more. They're still trying to figure that out.
Well, at some point it becomes a star cluster, wouldn't you think?
Not at these low levels
Oh, really?
and these separations.
There's a great science fiction story about a planet that's in a system that has, I think, 5 stars.
Yeah.
And every every tens of thousands of years, you end up with all of the stars being such that night falls on the planet, but normally night doesn't fall.
I remember that. I
Yeah.
remember that.
It's called nightfall.
It's called Nightfall. Yep.
Yeah.
It's actually a radio show too.
Well, that wasn't Luke Skywalker looking in the sky on the planet he was on with two suns up there, right? That's not the one you're talking about?
No, not at all.
That would have been a binary.
No, they were. This is one that Skyfall is the one where the entire planet was. They were trying to prevent mass panic.
Yeah. Because people had never experienced darkness
Yeah.
in their history, in their recorded history.
What do
But
you
some
think?
archaeologists are out digging and they find that, like at Troy, they find these different layers of civilization that have come and gone. And they notice there's a periodicity there. And at the same time, they've developed astronomy, and there's some astronomers saying, well, wait a minute, it looks like we're going to have this, essentially eclipse situation. Not really an eclipse, but night will fall.
Yeah.
And people just aren't used to having darkness. And so they go nuts, and there's
Yeah.
riots and civilization collapses.
They destroy each other.
Yeah.
Jerry, you know what a good topic might be for a future show? What would the sky look like for any alien civilization living on Proxima B or A or the planet that?
Well, we've had that. Before you remember, we've had speakers come and they would show you what the sky would look like from various other stars.
The planet
Constellations all change shape.
Proxima is the little star. It's a 3-star system, isn't it? Our closest neighbor.
Yes.
Okay, well, let's talk about meanings of magnitudes here, Mr.
Okay.
President.
Well, before you get to that, something else you touched on. The internet is getting worse and worse at science illiteracy. And one of them, there's a series of photographs going around that show what the night sky looks like from Mars. And the cameras on the rovers are not capable of taking those long exposure, tracking those things. And if you look closely at some of the pictures, they show the characteristic 6 diffraction spikes, the James Webb Space Telescope. And I said, well, I didn't know they put the James Webb Telescope on Mars. And on another one, I wrote back and I said, it's the same picture, the same sky you would see from Earth. But
Well,
yeah, go ahead.
Daytime on Mars is not a blue sky, is it?
The sky's typically red during the daytime and the sunsets are blue.
And then regular nighttime, you'd be able to see probably far more stars than we can at night.
Not through the rover.
Oh yeah, right. Okay, but if you were all right.
So anyway, I didn't find a good graphical way to represent the history, but it's very interesting because this scale goes really backwards. The brighter something gets, the lower its number. And apparently it started with Hipparchus back in 129 BC, where he was the first one to generate a really good star map. And so a lot of and he labeled a lot of the stars. So now we get Hipparchus numbers as a catalog of the brighter stars, because he didn't have any scopes. But he said he called the brightest stars of the first magnitude, and then meaning simply the biggest, and the second biggest, the second magnitude meaning second biggest, he called those 6th magnitude. So he set the first scale at the most important being the brightest one, and then going down in size to their level down from the emperor, you might say. So that set the backward range of it. Ptolemy formalized that, and it basically changed unchanged. It stayed unchanged for 1,400 years. Galileo, when he used his first telescope, he started resolving stars and seeing stars that were fainter than 6th magnitude. And so that extended the range of it. And since then, we've been, as I mentioned before, a 6-inch scope will see 13th magnitude stars. So someone formalized it, let's see, in the 19th century, Norman R. Pogson, an Oxford astronomer, claimed that 5 magnitudes of star brightness was defined as a brightness ratio of 100 to 1. And that's been the basis of our magnitude system ever since. Even though the system has been extended significantly, we get down to 20th magnitude. I think before the James Webb going up, the limit here was to 21, 22, 23 magnitude was the faintest stars I've ever seen anyone refer to. And then up here at 0, we have, what is that? It's first magnitude here. That's Vega, I believe. Is that right? And 0th magnitude star, I can't think of one off the top of my head.
Sirius is getting close. Well, Sirius is
But
minus.
seriously, it's negative, yeah.
Oh yeah, there's here. Rigel, Capella, Arcturus, and Vega are magnitude 0.
Yep.
And Vega is
And-
used to define the 0.
Right, that's right. That's how, yep. So Sirius shines at magnitude minus 1.5. Venus reaches minus 4.4. The full moon is about minus 12.5.
Mhm.
And the sun blazes at minus 26.7.
Right.
So are you saying that they had that minus part of the scale back before Galileo and then?
No.
Oh,
No.
no.
Adding them to the
They
scale
added them.
was possible after the Pogson rule.
And
Because he
that was
defined it
the original scale was 1 to 5,
1 to 6.
1 to
1 to
6.
6.
Yeah.
Even though where is it that it disappears to the naked eye? 5 or 6?
6.
6.
6.
We could see some, the tiniest little specks are 6 probably.
Or if you go to a super dark sky, you can see down to 7.
Really?
If you have good eyes.
Yeah.
Now, Tommy, you used to say that the magnitudes were logarithmic.
Yeah.
Right, they are. So basically, can you see his, let's see. Basically, it was the Germans in the 1800s that established, the scale precisely. And what they use, as Jerry said, if you differ in magnitude by 5, it's a factor of 100 in brightness. And so if you take the fifth root of 100, okay, you will get 2.512, which is what Jerry has, kind of like the mid-range of this guy here. You see that 2.5 to 1?
Yeah.
Yeah, so that's basically it, Tim. It's the fifth root of 100. So you just put that in your phone, in your calculator on your phone, and you'll see that the fifth root of 100 is 2.512.
Mhm.
And it goes on and on and on. It's an irrational number.
Yeah, I cut a lot of this discussion out because it's hard to show.
Right,
Pictures.
right.
Yeah.
Yeah.
But accurate. Yes. Thank you, Tom.
But no, you have it nailed. I mean, Jerry, you have differences and then what they mean in brightness.
Yeah.
Tommy, we'll continue this in our math discussions.
Oh, sure,
And
sure.
again, if you have any type of software for tracking or camera control or photographing, recording the image, you can do photometry, which is accurate measurements of these magnitudes. It'll do it for you if you're careful. It will do it for you wrong if you're not careful.
With the phone?
With any kind of software that you let it look through your telescope at stars and it can record the stars, then you can do photometry with it.
Oh, wow, cool.
Yeah.
The way to do it, they did it was they established several stars that they knew the brightness of it, and then you compare neighboring stars to it. Is this between that star and those stars or not? That's how they did it visually, and that's how amateurs did it up until this software became available in probably the 1990s.
All right. That's how this amateur did it, Jerry, in 1965.
Yeah.
Comparison charts.
So there's a software that'll tell you exactly what that star is, magnitude-wise? Is that what you're saying? You don't have to determine it.
You can measure the brightness of the star quantitatively. Okay, now the program has got these things in error in the wrong order. But this shows M34, a small open cluster near the Pleiades, near the Little Dumbbell Nebula. And this shows the Algol, the demon star, artist rendering of it. Now, the thing that happens here is that the Algol is an eclipsing binary with a long period of eclipses. And the minima of Algol were plotted in Sky and Telescope when I was first starting out in this. And it changes by several orders of magnitude, not orders of magnitude, it changes by a noticeable amount. So
it's about half brightness.
Yeah. And this is M34 in that same region of the sky, a nice tight little cluster, open cluster.
Well, that Algol there comes from Ras Al Ghul, which is Arabic for head of the demon.
Uh-huh.
and it's the eye of the Medusa monster. And the story was it was winking back at the Earth because they noticed that it changed in brightness way back in
Yeah, it was noted. It was called the Demon Star
yeah.
because of that blinking.
Yeah.
Now, in these times, ancient times, oh, I've got a sneezing fit.
Yeah.
No, it's not you, princess.
Yeah.
So the cat objects when I sneeze.
Yeah. That star also.
It hurts her ears.
Yeah.
But they thought that these, when we were looking at the sky, we were looking into heaven, like the religious heaven. And these were things, they were gods and creatures and angels and all sorts of things. So they ascribed this to a winking demon. And one of the first guys, whose last name was Bruno, I forget his first name, but he came out with the revolutionary idea that the moon is not really a celestial body in the religious sense. It's
Was
just
that Giordano?
Giordano
Yeah.
Bruno. Yeah.
Bruno.
And so he was just a big rock. And so everybody heard that and they burned him at the stake. So
Yeah.
Well, what they really got him for was saying that there are living creatures out there on other worlds.
yeah,
Right. 1600, the year
yeah,
1600.
1500s.
Well, we still don't know that.
Yeah, but isn't that something, Ronnie? If you had an idea and you said something, they'll burn you at the stake.
Yeah.
I'm waiting for some big televangelist to finally embrace astronomy, the stuff we know is out there, and suddenly make dark matter heaven. That's where we're all going. We're going to become wimps.
Yeah.
And they'll burn them.
Well, the current government is working on burning you for saying just about anything.
Yeah, you're pointing out anything true about the universe. It's
Yeah.
gotta,
And
it's
if
gotta
people
fit the
have a nice
box.
pair of binoculars, Jerry, this is a really nice object.
Yeah,
This open cluster.
yes, it's very pretty. And you can see here some distinctive. Now, when you do these processes, you photograph it and you process it. Very frequently, if you don't watch it, as you do the different steps, the colors fade. So you have to resaturate at key points to keep the colors in there. And this guy did a good job of it. You can see the red giant stars. You can see the white hot stars. Colors are really good in this one.
And Jerry, when you use like a star exterminator, can you tell it to feather the stars? In other words, get rid of up to a certain magnitude so you can keep some in?
You can.
Okay. That would be kind of important if you wanted to.
It's more threshold brightness. You just set the brightness threshold at something, and then only the brighter stuff shows up. But Star Exterminator sets its feathering. Feathering is a different word in
okay.
processing. Feathering is when you substitute in a sharp image of a nebula, and you want to put it in a picture because when you process the background, it causes the image to blur
Saturate.
Thank you. And so you process the bright image and then you paste it back in over the image, the faint image, and you have to do the edges because that sometimes will show sharp edges. So you feather the edges, you blur the edges of each picture, so it doesn't give you a sharp artifact.
Okay.
You know, I did that with Bob Richards' photograph of M42.
Yeah.
Blown out the middle, and I took my picture, I rotated it and scaled it and pasted it in the middle of his picture so that the middle, you could see it. And I did that with a very fuzzy edge on the paste. And he liked it so much, he had it printed on metal and hung in his house.
Yeah, it's a very pretty good picture. The two objects, M31 and at least, as you point out, M42, are almost probably impossible to do a single process on because the contrast, the dynamic range of brightnesses is so different in the same picture. So anyway, that
Can I throw one repeated question? I've asked this before. I try to imagine being on an exoplanet orbiting one of those stars in the star cluster. We're talking light months away, right? We're 4.5 light years away from Alpha Centauri, but that's not how it is in a cluster, is it? Their night sky is filled with little suns and very bright stars, aren't they?
Yeah,
Are we talking
mostly little faint ones.
light weeks apart, light months, light?
Light days, light hours if you're in a dense globular.
Good Lord. Okay. What is this? Another cartoon?
This is a topic we're not going to do today. We're going to do it next week because I've only got 1 minute. This is simultaneity. It's a simple operation, a simple observation. It's a Gedanken experiment that Einstein did that sent him on the path of relativity of time. What is to define simultaneous?
Except he didn't have rocket ships, so he used a train.
Yes, that's right. He used the train. The train is traveling at a significant fraction of the speed of light, but it's still a train.
Yeah.
So anyway, we'll get to that later because this is one of the single greatest thing. This inherent in all classical physics and exemplified in Newton's 3 laws of motion. Time is absolute. It's fixed. It's in the background. Everybody sees it the same. This one convinced Einstein that time is not a fixed thing. You experience time in relation to where you are and how fast you're moving.
Mhm.
So and anyway, that's the key opening element to modern relativity. And we'll cover this at the start of next week.
Fantastic. Fantastic.
I have a feeling we're all going to get lost.
It's a good program.
Oxford Dictionary still defines it as the order of events. I don't think there's any other way to define time. Well,
The
gentlemen,
order of events is different from where you are and how fast you're moving.
that's probably true. They're going to have to
You
add.
can actually look into people's past or into their future a little bit, depending on where you are and how fast you're going. And that led to the suggestion or hypothesis that the past and the future always exist, even though you're not experiencing them at the moment.
Mhm.
Well,
That
does
is, the past doesn't disappear.
does the big collapse in the future of the universe mean we're all going to live our lives backwards, you suppose? Hey, listen,
No, I don't
did you learn
understand
a
that.
lot, Tim?
Maybe we are living them backwards. Who knows?
We probably are. We're in a black hole. Did you learn a lot, Tim Crawford, like I did?
I'm remembering the future already.
Well, I try to remember and I just can't. We're going to meet back here on the Zoom screen again next Monday morning, everybody, for the SBAU Astro Hour number 243. Please tell your friends about it. Until then, sayonara, adieu.
Thank you, guys.
Adios.
Bye.
And as